The velocity of our development process is directly tied to the quality of our data infrastructure.
Welcome to Talking Autonomy. In this episode, we're going to dive into the data behind Ghost, and specifically, what are some of the major data flows of how we take data from cars all the way through machine learning back out to cars again. So I'm joined today by Scott. Scott, why don't you introduce yourself, give us a sense for what you do here, and maybe what you did in your career previously.
Sure. So before Ghost, I was in finance. I was at Jump Trading for about 7 years. And there I was primarily responsible for building out our research infrastructure as well as some bits of production infrastructure. More or less doing the same thing here, honestly. The name of the game is data, and you have to get that in, sanitize it, work with it, use it.
Yep, either way, autonomous driving, finance, a ton of data that powers, the engine above. All right, so, as we said in the onset, we're just going to try to give people a sense for the various major data flows through the company and how we move data around and leverage it for our various processes. So why don't you give us just kind of a high-level view of that? What are the big areas of data?
Yeah, so the 30,000-foot view is that all of our data essentially comes from the cars. The cars are recording, and that flows into the data center. And once it arrives in the data center, we do lots of validation and metrics. And so that's how we validate the drives. And then at the same time, the data is also used as an input for training. So machine learning requires data, and this is the input to those models. And then from there, it flows back out to the car once those models have been trained.
Okay, makes sense. All right, so let's start with that infrastructure around just kind of understanding and driving. We're out driving every day, all times of the day, et cetera. And it's important that we kind of learn from all those drives, right? And maybe in the very beginning it was okay to have some people in the car and said that felt good, or there was a problem here or there, but we quickly scaled beyond that, where we realized we needed real infrastructure to be able to understand what a drive looked like and help improve. And so walk us through that pipeline. How does that work?
Yeah, so the car is recording, and every 2 minutes it cuts a new release, and it's going to push that 2-minute chunk to our data center. It lands in the data center basically just as a file, just a file on disk. And then we ingest that into a custom in-house storage framework for working with time series data.
And this data that comes up every 2 minutes, it's a combination of kind of like video data plus telemetrics and other stuff?
That's right. So we're directly recording a number of raw sensors, anything from brake pressure, steering angle, are the windshield wipers on, that kind of thing, as well as a lot of internal state from the driving program. Once it arrives, we have to fill in a bunch of gaps, though, because we're producing so much intermediate state in the driving program that we can't afford to save and upload all of that. So what we do is, as soon as it arrives in the data center, we will run in exactly the same code as in the car, fill in all of those gaps so that we have a more complete view of exactly what was going on in the car. And then these are the inputs to the next step, which is going and calculating a bunch of post-drive metrics. So validation of drive performance, looking for any outlier events, anything that we want to keep an eye on. And then that is sort of the input to how we monitor our driving performance. So we're going to be looking at aggregate statistics on that. We're going to be looking at outlier events. We're going to be using that to say, is this release better than the last release? Are things improving? Have we regressed? That kind of thing.
Yeah, okay. So basically, on a per drive basis, we get these KPIs, if you will, and obviously that allows us to kind of understand that individual drive, but also all of our drives on a whole. Why don't you give us a little more color on what some of these KPIs are? What are we looking at as some of the key measures of drive quality?
So we're looking for two kinds of things primarily. One is more like normal driving data, follow distance behind another car, speed, that kind of thing. And then others are more like outlier events. So if we have a hard brake tap, if we are weaving in the lane, if we're hugging to the right in the lane, these kinds of metrics are mostly driven by human observation, where some human noticed that something a little off was happening, and then from there we go and create a more rigorous, quantifiable metric that we can then apply to all of our drives to get a more statistically meaningful sense of how often it's happening, if it's happening more or less.
Yeah, I see. I mean, obviously, if there's a kind of difficult situation on the road, there might have been a good reason to slam on the brakes or to veer or something like that. But if that's happening a lot or more than not, it's something to look into.
Right.
So it sounds like these KPIs essentially allow our engineers to look out for and find things that might be awry in some element of the product. How does that triage process work? Say we go on a drive and we come back. How do our engineers kind of first of all understand if there was a problem and then ultimately take that through to a form of resolution?
Yeah, so the basic life cycle of triage at Ghost is data comes in almost real time as the cars are driving. Then we will go through the pipeline that we discussed earlier where that data comes in, we fill in the gaps, then we do a bunch of additional metrics. These land on a dashboard, and that dashboard is something that people are going to be watching and looking for. Is this happening more? Is this happening less? How does this release compare to the last one? The overall life cycle of this process is basically one where there's a human that observes something inappropriate or unusual or unexpected. Then we create a metric to track that. Then we scale that metric out to every drive. We will backfill and say okay, we just noticed it now, but has this always been happening?
Yeah, you can replay, right? So we can go, basically find that metric across previous drives.
Exactly right. And so then once you have those statistics, then you can start to correlate, is this event happening more or less around bridges or overpasses or cracks in the road, or you can find what things seem to be causing it, and that's incredibly useful in solving it. So once you know what's causing it, that gives you the tools to try and fix it. And then once you have rolled out some changes to try and improve that, then the loop closes, and now you're back to looking for something new that's happening that's unexpected, and you're also keeping track of this metric forever now.
Right.
Once it's on your radar, you can just watch it forever, and you can make sure that you're not getting worse at it, and hopefully keep getting better.
Yeah, and of course, as engineers build new features, we're now just kind of building these metrics in from the start. So, part of the process is designing a feature is understanding how to measure its quality, and from day one, we're essentially building those metrics in. That's why it's ever growing, right?
Yep, that's right.
So you guys also have a number of tools for visualization of this data, because sometimes when there's a problem, you just want to be able to dive in and see the scene and see see what radar saw, see what vision saw, see what the drive program did. How does that infrastructure work?
Yeah, so we have a number of tools for visualization. The range runs from something like Foxglove, which is a very optimized tool for robotics, where in the world of robotics, it's very common to have a lot of different data streams that are all happening in the same synchronized time stream, and you want to visualize them together in some coherent way. And so Foxglove is great for that.
And that allows an engineer just to turn off all the layers of information and say, I want to see what radar saw, or I want to see vision, and just replay the scene over and over and really get a sense for what happened.
That's right. It's primarily useful for looking exactly at what was happening in a car at one time. So it's mostly a point-in-time, time series sort of view of the world. In contrast to that, we've got something like Kibana, which is a dashboard that is sitting on top of Elastic, and that's useful for computing aggregate statistics. You want to see just in the last hour what's happened. You can see it there in almost real time. And then you also have the option as a model engineer. You will often want very granular control over the analysis that's being done. So we also have a lot of direct APIs to the data itself so that you can pull down the data and directly explore it.
Yeah, sounds powerful. I mean, go a little deeper on that. I mean, given all these cars, all these drives, all this data coming in, what does this data infrastructure look like underneath? What are some of the tools we use to manage this huge amount of data?
Yeah, so to get something like real-time performance, we use Kafka as an event-driven framework for, the first message comes in from the car, and that starts the chain of events. And then every processing step from there is consuming from these topics and pushing to notify the next consumer. And so in this way, we can flow very directly from ingest to the first incorporation into our structured time series storage. We do a bunch of indexing. We go and do the rehydrate process that I described earlier. We will compute all of these post-rehydrate statistics that are useful for KPIs and tracking metrics. We also will go and export this data in a variety of forms that are optimized for the different view layers. So Foxglove requires its own file format. So that, as a part of that stream, we're generating that. Kibana is also its own unique storage layer, so we have to export to that as well. All of these pieces are flowing continuously from the moment that the data arrives.
All right, but it's ultimately trying to keep an underlying source of truth and then creating all these different views into it, essentially.
Exactly right. Yeah, so the way that I think about data is one where you always can only ever have one source of truth. You know, with the old adage that a man with one clock knows what time it is, a man with two can never be sure. So you have to have exactly one source of truth, and that should be immutable and never changed. So that's the raw files that come in from the car, and everything after that is derived. And many of those layers are specialized for a purpose. So when we ingest from that raw file, we're converting that like file on disk into a database entry that is optimized for retrieval, for selection by slicing by time range and asking for particular columns of data. And this is very general, and it's very useful for our compute framework, but it's also not like a relational database, so it's not as good for some kinds of query expressions that you might want to do. So that's why you end up exporting to Kibana. And similarly, Foxglove wants its own particular way of seeing the data, which is just like a pure events in a stream. And so that's another thing where we're creating another layer on top of our primary storage that is optimized for a particular form of consumption.
All right, makes sense. So let's dive into a whole different area. The same data that we're collecting and we've been talking about so far is also used to basically power our machine learning model training environment. Walk us through the data flows within that part of the world and how model engineers ultimately use it to train models.
Yeah, so in contrast to everything we've talked about up to now, which is all event-driven and streaming and kind of real-time, the model training process is a little bit more human-involved, where you're going and saying, these are the scenarios where our car is performing well, this is the scenario where they're not, and we're going to go and try to find new sources of data that will fill in those gaps so that we can improve our models. So there's this sort of data exploration process where you're going and using the ways that we have indexed the data so that you can find what you're looking for, and then incorporate that into your training set. So our training infrastructure sits primarily on top of the time series storage layout that I've described. And so basically what happens is we'll define a training set, and then we'll extract from that primary storage into yet another optimized view of the data, where for machine learning, in general, the way you want data formatted is as rows. So you want to have like a pre-formatted bit of data that can be used as an input for regression. And so that's the way that we will sort of rotate it from the column-based sort of events that are the natural format of the data into this row-based view that is optimized for training.
I mean, so to just use an example, one of the earlier videos, we talked a little bit about our lane marker network and that ultimately understands pain on the road and gives us kind of lanes. And that's a good example of where we have so many hours of driving out there, but we need to find a representative set of training data that has all these different types of lane markers of all shapes and sizes and all different orientations and all different colors and all different times of day. And so those are all curated based upon that data being labeled so the model engineer can find the right pieces and then pull together in this set, correct?
That's right, yeah.
Okay. All right, and so once data is ultimately pulled and reoriented like that, what happens from that point forward?
So from that point, it's primarily in the land of training, which means that it's training in PyTorch or TensorFlow, something like that, and then visualizing in something like TensorBoard. And then once that training is done, then there's a validation loop that will go and take the models that have been produced and try to score them on the training data and see if it's improved. And then eventually that we'll pick the one that we like, and that goes back into the car.
Yeah, and within those steps, you can also kind of run these new models through various forms of simulated testing, and maybe that kind of gets us into the last topic, which is we're using simulation pretty broadly throughout our cycle as well. What are some of the elements that we take advantage of simulation for?
Yeah, so simulation is a great way to explore the parameter space of your program. If you think of a program as essentially a function that takes many inputs, the space that function can cover is enormous. And it's much more than you can reasonably expect to feed from like just plain recordings. So what we'll do is we'll generate a wide range of scenarios that cover a lot of that parameter space and evaluate what the program will do in all of those cases. And so this is a great way to validate that you've covered corner cases and that as you make changes to code, you can very quickly evaluate all of the simulated data much more efficiently than if you were trying to run the driving program on raw video.
Right. Yeah, I mean, the driving program is a great example of this, where ultimately we might want to put it in situations that are pretty hard to recreate on the road. If somebody just like hard comes in front of you, or there's really nefarious actors or things like that, and so we can do that via simulation, see what happens, and it's the same infrastructure.
Right. So if we want to run the driving program on a recording, what you're going to be doing is taking video and sensor data from the car and running through the whole perception part of the program. And only then do you get to the part where the planner is trying to make its decisions. Right. So if what you care about as a developer on the planner is evaluating if you have improved the planner, you really would like to just cut out the perception piece and just directly simulate the inputs to you as the planner. And so that's one of the places where simulation really shines, is that you don't really need, you can skip the pieces of the program that you don't need and only simulate the pieces that you care about.
Yeah, makes a ton of sense. Well, Scott, thanks so much. This was a very brief overview, but it gave us a pretty good sense for how data flows through Ghost. Coming off cars, coming into our system to be able to use to score drives and constantly improve, but also feeding the machine learning and simulation processes to help our engineers go faster. Thanks so much.
Of course.